Let's start with the warm-up. We're going to multiply the two binomials 2x plus 5 times x minus 3. So there's two ways that we learned how to do this. We could FOIL or we could use a rectangle. So I'll show the area of this by using a rectangle. We have 2x plus 5 times x minus 3. And if we stick that in the rectangle, we can find the area of each box. So the first box is 2x times x, and that would give us 2x squared. The second box would be 5 times x, which would give us 5x. The next box would be 2x times negative 3, which would be negative 6x. And the last box would be 5 times negative 3, which would be negative 15. So if we combine like terms, we can put our x's together. We'll also put it in standard form where we have the highest power of x first. We'll get 2x squared minus x minus 15. And this trinomial represents the product. So when we multiply these two together, here's the answer, 2x squared minus x minus 15. So today we're going to review factoring. So the opposite. Factoring is when I give you an answer and I say, all right, what multiplies to that? So let's do some examples, some easier examples here. What are some factors of 10? What multiplies to 10? Well, we have 1 and 10. We have 2 and 5. Also the negatives work, negative 2 and negative 5, negative 1 and negative 10. Let's take a look at 3x. What multiplies to 3x? We have 1 and 3x works, also negative 1 and negative 3x. We could break it up into 3 times x, also negative 3 and negative x. So these are factors, they multiply to 3x. How about factors of 4x squared? Well, we could do 1 and 4x squared, also the negatives. We could break it up and do 4 and x squared. Oops. Also negative 4 and negative x squared. I won't write that up. We could also do 2x and 2x. We could do 2 and 2x squared. These are all factors of 4x squared because when we multiply them together, we get 4x squared. So factors are things that multiply to the number that we start with. So there are three ways of factoring. Yesterday we looked at two of them. The first was pulling out a greatest common factor. So GCF again stands for greatest common factor. A greatest common factor, you look at your terms. A term is each item in your expression that's separated by the plus or minus. And you look at each term and decide what's the biggest number or letter that you can divide out of each. So if we have 12x and 6, the biggest thing I can divide 12 and 6 by is 6. So I'm going to pull that out. We're going to divide each of the terms by 6 to see what's left over. 12x divided by 6 is 2x. 6 divided by 6 is 1. You can check your answer by distributing, and you should get what you started out with. 6 times 2x is 12x. 6 times 1 is 6. Let's try the next example, problem B. First look at the 2 and the 4. The biggest number you can divide 2 and 4 by is 2. Then look at your x's. We have x squared and x. We can divide each of those by the smallest amount of x's. In other words, here it's x. So we're going to divide each by 2x. When we do that, we're left with 1x plus, here the x's cancel, 4 divided by 2 is 2. And again, if you want to check your answer, you can distribute and get what you started with. All right, the last thing, we have 2x squared, 4x, and 6. We can divide 2, 4, and 6 all by a 2. The 6 doesn't have an x, so we cannot divide any of these terms by any x's. So here's just 2. Divide everything by 2. And we'll get x squared plus 2x minus 3. Okay, so that's greatest common factor, and you'll want to check for that first. Is there anything you can divide out of each of the terms? The next example is box and circle, and you're going to want to use this if you can't pull out a greatest common factor, and there's 3 terms. So to use a box and circle, we're going to make a box. We'll put a circle in it. We put our terms starting in the upper left-hand corner. We have 2x squared The middle term goes in the middle, 9x, and then the 4 goes on the bottom. So we want to think of two things that multiply to our first number times our last number. So it multiplies to 8x squared. That adds to 9x. So we're going to think of factors of 8. What multiplies to 8? Well, 4 and 2 do, but do they add to 9? No, they don't. So 4 and 2 will not work. How about 1 and 8? And that does work. 1 and 8 multiply to 8, and they add to 9. So they have to meet both of these qualifications. And then we'll put an x with each one of them. And now they multiply to 8x squared, and they add to 9x. So you can put these in the diagonals in either order. Now we get the outside of the box. So we want to know what multiplies to 2x squared. Well, that would be 2x and x. Be careful where you put the 2. If you put the 2x here, it's really easy to get the 8x. If you were to put the 2x on the side here, you'd have to multiply by decimal to get the 1. So we don't want to put it on the side. We're going to put it on the top. So we know that 2x times 4 is 8x. And we know that 2x times x is 2x squared. X times 1 is 1x. And so now we've factored the outside of this, so we can write in either order our 2x plus 1 and our x plus 4. So here are the two factors of the trinomial. So we took this and we found two things that multiply to this. Let's try the next one. Again, we'll make our box and circle. So we have our x squared, our negative 2x, our negative 15, and we want to know what multiplies to the first term times the last term. So it multiplies to negative 15x squared. That adds to negative 2x. So things that multiply to negative 15, that would be 3 and 5. Can I somehow manipulate those so they multiply to a negative 15 and add to a negative 2? Well, if I make the 5 negative, then it multiplies to negative 15 and it adds to a 2. So now in either order, we're going to put our terms in the leftover boxes, 3x and negative 5x. And we want to think of two things that multiply to x squared. That would be x and x. X times 3 is 3x. X times negative 5 is negative 5x. So when we write our terms, we can write them in either order, x minus 5, x plus 3. All right. Let's do the same thing with C, D, and E. These are things that we haven't looked at before. But we can still use the box and circle. So here I can't divide out a greatest common factor of x squared and 9. So let's put this right into a box and circle here. So the first term is our x squared. There's no x term, so I'm going to put a 0x, but we have our negative 9. So I want two things that multiply to the first and the last box, multiply to negative 9x squared, that add to 0x. Okay, so factors that multiply to negative 9 add to 0 would be negative 3 and 3. And that works. They multiply to a negative 9x, add to 0. So if we get the outside of the box, what multiplies to x squared, that would be x and x. X times negative 3 is negative 3x. X times 3 is 3x. So this is x minus 3, x plus 3. All right, in class I have you try two more. So let's try this one. So we have x squared, and we have our negative 49. Again, there's a 0x here. We want to know what multiplies to our first and our last box, negative 49x squared. That adds to 0x. All right, so two factors that multiply to negative 49 add to 0 would be 7x and negative 7x. So then what multiplies to x squared, x and x? X times what gives you 7x? That would be plus 7. X times what gives you negative 7x? That would be minus 7. And so this factors into x plus 7, x minus 7. So start looking for a pattern here. I'm going to put a box around our answers. And let's do the last one in our box and circle. We have our x squared, our 0x, our negative 100. We want to know what multiplies to negative 100x squared. That adds to 0x, and that would be negative 10x and 10x. So let's factor the outside. We'll get x and x minus 10, x plus 10. So here's the factored form. I should keep it consistent. X plus 10, x minus 10. So if you take a look at our three examples here, what do you notice about the x squared minus 9 and the answer? The x squared minus 49 and the answer, the x squared minus 100 and the answer. Well, if you notice, all of these, you can get these numbers 9 and 3, 49 and 7, 110 by taking the square root. The square root of x squared is x and x. The square root of 9 is 3 and 3. The square root of x squared is x and x. The square root of 49 is 7 and negative 7. Same with the 100. The square root of 100 is 10 and negative 10. The square root of x is x and x. So let's talk about this pattern here and what it's called. This is called difference of squares. So in order to use the pattern, it has to meet two qualifications. They have to both terms have to be square numbers, and they have to be subtracted. If they're not being subtracted, you can't use the pattern. And if both numbers aren't square numbers, you can't use it. So square numbers come from finding the area of a square. For example, a 1 by 1 square is 1. A 2 by 2 square is 4. So 4 is a square number. A 3 by 3 square is 9. 9 is a square number. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. All the way up to x squared, which is a square number. It comes from x times x squared. All right, so how do we use this pattern? If both terms are square numbers being subtracted, you take the square root of each one. So the square root of x squared is x, so I'll put two sets of parentheses. Two x's, put a plus and a minus. The square root of 25 is 5. So in either order, you can write x plus 5, x minus 5. For the next one, take the square root of each. So we do x plus, x minus. The square root of 81 is 9. For the next one, the square root of 4x squared is 2x. So you can do your two sets of parentheses. We'll do our plus and our minus. The square root of 16, I think I covered this up right here. Yep, that's the square root of 16 is 4. So when you're doing these factoring problems, you should look for this pattern first. You should look for two terms. If they're square numbers being subtracted, use difference of squares. And if that doesn't work, you should next try greatest common factor and pull that out. And if that doesn't work, you should try box and circle. So today you're going to practice these three methods of factoring, and we'll do this more tomorrow as well.